In a heart-stopping revelation that has set the astronomical world ablaze, the James Webb Space Telescope has shattered the boundaries of human understanding by detecting an astonishing 750 galaxies lurking beyond what was once thought to be the edge of the observable universe. This is not just a discovery, it's a cosmic earthquake, a moment that redefines the very fabric of reality and challenges everything humanity has ever believed about the cosmos. These galaxies, shimmering in the deepest reaches of space, are not faint whispers or fleeting glitches. They are bold, undeniable signals of entire galactic cities thriving in a realm that, by all accounts, should be invisible to us. The implications are staggering, the questions overwhelming, and the wonder boundless. Smash the like and subscribe buttons to dive deeper into this universe-altering breakthrough. The observable universe has long been defined as the vast bubble of space that light has had time to traverse since the Big Bang, some 13.8 billion years ago. Stretched by the relentless expansion of space, this cosmic horizon spans roughly 46.5 billion light-years in every direction, encircling Earth in a sphere of visibility. Beyond that limit, conventional wisdom dictated that nothing could be seen, not because it doesn't exist, but because its light hasn't had the chance to reach us. For decades, this boundary was considered an impenetrable wall, a fundamental limit woven into the laws of physics. Yet, in a feat that defies imagination, the James Webb Space Telescope, with its unparalleled infrared vision and cutting-edge optics, has pierced through this veil, unveiling 750 galaxies that appear to exist just past the edge of what should be observable. This is not a minor anomaly, it's a seismic shift that demands a complete rethinking of cosmic boundaries. What makes this discovery so electrifying is the sheer clarity of the data. These are not vague smudges or ambiguous signals. The detections are robust, meticulously verified across multiple observations, and painstakingly scrubbed for any hint of instrumental error or cosmic interference. The galaxies are real, their light traveling across unimaginable distances to reach the telescope's golden mirrors. Initial analyses suggest these are not primitive gas clouds or embryonic star systems, but fully formed galaxies, some boasting intricate structures like spiral arms, dense star clusters, and even hints of supermassive black holes at their cores. Their light, reddened by the vast cosmological distances, carries the unmistakable signature of mature stellar activity, suggesting lifespans that may stretch billions of years into the past. The idea that such complex systems could exist in a region thought to be beyond our reach is nothing short of mind-blowing. This breakthrough raises a torrent of questions that strike at the heart of cosmology. Are these galaxies part of our universe, or do they belong to a separate cosmic domain with its own rules and initial conditions? Could their light be reaching us through some exotic bending of space-time, perhaps amplified by gravitational lensing on a scale never before imagined? Or, in a twist that would upend everything we know, is the observable universe just a tiny fragment of a far grander, more intricate cosmic tapestry? The James Webb Space Telescope, designed to peer deeper into space and further back in time than any instrument before it, was built for moments like this, moments that force humanity to confront the unknown and rewrite the story of existence itself. The telescope's ability to achieve this feat is a testament to human ingenuity. Positioned at the second Lagrange point, cooled to near absolute zero, and equipped with a sunshield the size of a tennis court. The instrument operates in the frigid silence of deep space with flawless precision. Its deep field imaging protocols, which involve staring at a single patch of sky for days or even weeks, allow it to capture the faintest whispers of light from the most distant corners of the cosmos. Advanced algorithms and machine learning models sift through terabytes of data, separating genuine signals from the cosmic noise of dust, radiation, and nearby stars. The result is a triumph of technology and curiosity, a moment where the boundaries of the possible have been obliterated. The galaxies themselves are a treasure trove of cosmic secrets. Spectroscopic readings reveal that some contain heavy elements, carbon, oxygen, nitrogen, forged in the hearts of ancient stars. These elements, thought to take billions of years to form, suggest that star formation and nucleosynthesis may have occurred far more rapidly in these distant realms than current models allow. Others show signs of complex morphology, with tightly wound spiral arms and globular clusters that hint at a rapid organizational process. Some even appear to harbor massive black holes, far larger than expected for their age, raising the possibility that primordial black holes, formed in the universe's earliest moments, may be more common than previously thought. Each galaxy is a time capsule, its light carrying stories of cosmic infancy, the first stars, and the dawn of structure in the universe. The discovery also challenges the very foundations of cosmology. For decades, scientists have assumed that the observable universe was the limit of what could be accessed, a finite sphere within a potentially infinite cosmos. Yet the James Webb Space Telescope's findings suggest that this boundary may be more permeable than imagined. One possible explanation lies in cosmic inflation, the rapid expansion that occurred fractions of a second after the Big Bang. Some models of inflation predict the existence of bubble universes or isolated pockets of reality, each with its own physical constants and evolutionary path. Could these galaxies belong to such a bubble, their light somehow leaking into our own cosmic domain? The idea, once relegated to the fringes of theory, now demands serious consideration. Another possibility is gravitational lensing, where massive objects like galaxy clusters bend and magnify light from distant sources. However, the sheer number of galaxies, 750, spread across the sky in a statistically uniform distribution, strains this explanation. Lensing can amplify individual objects, but the scale and consistency of these detections suggest something more systemic, as though a cosmic curtain has been pulled back to reveal a hidden stage. Some theorists speculate that the universe's geometry itself may be at play, with light traveling along curved or folded paths through higher dimensional spaces. If true, the James Webb Space Telescope may be acting not just as a time machine, but as a multidimensional lens, capturing signals that slip through the cracks of our three-dimensional reality. The implications for dark matter and dark energy, which together make up roughly 95% of the universe's mass energy, are equally profound. These mysterious phenomena are inferred rather than directly observed, their effects seen in the gravitational dance of galaxies and the accelerating expansion of space. If the James Webb Space Telescope is now peering into regions beyond the observable boundary, it may uncover new distributions of matter and energy that defy existing models. Perhaps dark matter behaves differently in these distant realms, clustering in unexpected ways. or maybe entirely new forms of matter or energy exist, reshaping our understanding of the cosmic balance. Each new galaxy is a data point in a puzzle that is growing more complex by the day. The discovery also forces a re-evaluation of time and causality in the cosmos. If light from these galaxies has reached us, despite the supposed limits of the observable universe, it suggests that the temporal structure of reality may not be as fixed as once believed. Some theorists propose that time itself could have different textures or rhythms at extreme cosmic scales, with cause and effect bending in ways that defy intuition. What was once the realm of speculative philosophy is now inching toward scientific debate, thanks to the telescope's unprecedented data. The idea that the universe might not be a single, linear narrative but a layered, multi-dimensional story is both thrilling and humbling. The psychological impact of this discovery cannot be overstated. Every major leap in astronomy has chipped away at humanity's sense of centrality in the cosmos. From Copernicus displacing Earth from the center of the universe to Hubble revealing countless galaxies beyond the Milky Way, each step has expanded the scale of reality and diminished our place within it. Now, the James Webb Space Telescope has taken this arc further, pulling back the cosmic veil to reveal a universe that is not just larger, but infinitely richer and more complex than imagined. Within this humbling revelation lies a paradoxical majesty, a recognition that humanity, though small, has built tools capable of touching the edges of eternity. The technical achievement behind this discovery is staggering. The telescope's ability to detect such faint signals relies on its 6.5-meter primary mirror coated in gold to optimize infrared sensitivity. Its instruments, including the near-infrared camera and mid-infrared instrument, are designed to capture light from the universe's earliest epochs, when the first stars and galaxies formed. The data processing pipeline, which involves calibrating raw images, correcting for cosmic rays, and aligning multiple exposures, is a marvel of computational astronomy. Machine learning algorithms play a critical role, identifying patterns that might elude human eyes and flagging candidates for further scrutiny. This interplay between technology and discovery is reshaping astronomy, turning it into a discipline where artificial intelligence is as vital as the telescope itself. The galaxies also offer a glimpse into the universe's chemical evolution. The presence of heavy elements in these distant systems suggests that stars lived and died far earlier than expected, scattering their ashes across space to seed new generations. This rapid nucleosynthesis challenges models of stellar evolution and raises questions about the conditions of the early universe. Were these regions denser, hotter, or more turbulent, allowing stars to form and explode in rapid succession? Or did some unknown process accelerate the production of elements? The answers could rewrite the timeline of cosmic development, pushing back the era of star formation to moments closer to the Big Bang. The discovery also has practical implications for future observatories. Telescopes like the Nancy Grace Roman Space Telescope, set to launch later this decade, are designed with the assumption of a fixed observable boundary. Now, mission planners may need to recalibrate their strategies, prioritizing deep field surveys and spectroscopic follow-ups to explore this newly revealed frontier. Ground-based observatories, equipped with adaptive optics and massive mirrors, could complement these efforts, providing high-resolution data to confirm the telescope's findings. The race is on to map this extended cosmos, with each new observation adding to a picture that is both breathtaking and bewildering. The galaxies also challenge our understanding of galactic evolution. In the Standard Model, galaxies form gradually, starting as small clumps of gas and dark matter that merge over billions of years to form spirals, ellipticals, and irregulars. Yet some of these newly detected galaxies appear to have formed complex structures far earlier than expected, with features like globular clusters and high rotational velocities. This suggests either a faster formation process or an entirely different evolutionary path, perhaps driven by unique conditions in their cosmic neighborhood. The possibility that these galaxies represent a new class of object, perhaps composed of exotic matter or governed by unfamiliar forces, adds an extra layer of intrigue. The discovery also reignites interest in cyclical universe theories, which propose that the cosmos undergoes a series of births and deaths, each cycle resetting the conditions for the next. If light from these galaxies has somehow survived across cosmic transitions, it could provide the first observational evidence of a universe that predates our own. Such a scenario would blur the lines between creation and eternity, suggesting that reality is not a singular event, but an endless procession. The implications for quantum cosmology, where the observer and the observed are linked through causality and information, are profound. If the James Webb Space Telescope is seeing beyond causal boundaries, it may be probing the limits of existence itself. The philosophical ramifications are equally staggering. The more the cosmos expands in our understanding, the more it challenges assumptions about what it means to be alive and aware in space. If galaxies exist beyond what was thought to be the ultimate limit, what defines the universe? Is it a singular entity or a porous network of realities bleeding into one another? These questions echo ancient debates about infinity and the divine, now reframed through the lens of empirical data. The telescope's discoveries are not just scientific, they are existential, inviting humanity to reimagine its place in a cosmos that defies containment. The cultural impact of this discovery will unfold over years and decades. Art, literature, and philosophy will grapple with a universe that is no longer finite, but boundless, its mysteries multiplying with each new observation. Religions may find new metaphors in these distant galaxies, seeing them as evidence of creation's vastness or the interconnectedness of all things. Educators will rewrite curricula, presenting astronomy as a static field, not as a completed field, but as a living quest, where every answer spawns new questions. Students will grow up in a universe with defined edges, but one where the unknown is the ultimate frontier. Economically and politically, the discovery will galvanize space exploration. Space agencies will vie for funding to launch follow-up missions, while private companies will see opportunities in developing technologies for deep space observation. International collaboration will become essential, as the scale of the cosmos demands a collective effort. These discoveries are not just data points, they are beacons, calling humanity to unite in the pursuit of knowledge. The James Webb Space Telescope has ensured that the next era of exploration will be one of ambition, cooperation, and awe. The discovery also reframes the search for life. Astrobiology has traditionally focused on nearby stars and planets, then cautiously expanded to distant galaxies. Now, the possibility that life, perhaps even intelligent life, exists in these remote realms challenges our sense of isolation. While detecting biosignatures at such distances remains a distant goal, the very existence of these galaxies expands the canvas of possibility. Life may not just be common, but ancient, widespread, and woven into the fabric of a cosmos far larger than imagined. The principle of mediocrity, that Earth is unexceptional in the grand scheme, gains new weight, suggesting that intelligence may be a universal feature, scattered across countless worlds. The James Webb Space Telescope's findings also hint at a universe that is multiply connected, where traveling far enough in one direction might loop back to the starting point. This topological complexity, long theorized in mathematics, could explain how light from these galaxies reaches us without violating physical laws. If true, it suggests a cosmos that is finite yet boundless, a labyrinth of folded space-time where distant realms are closer than they appear. The implications for navigation, exploration, and even communication across cosmic scales are tantalizing, pushing the boundaries of science fiction into the realm of possibility. The discovery also offers a new lens on entropy, the cosmic clock that measures the universe's descent into disorder. If these galaxies formed under conditions of unexpectedly low entropy, more ordered and structured than predicted, it could mean that time itself behaves differently in these distant regions. Causality, the bedrock of physics, may stretch or bend, with effects preceding causes in ways that defy intuition. Such findings would challenge the arrow of time, suggesting that the universe's narrative is not linear but layered, with multiple timelines interwoven across its vast expanse. The telescope's data also invigorates the quest to unify physics. For a century, scientists have struggled to reconcile general relativity, which governs the large-scale structure of the cosmos, with quantum mechanics, which rules the subatomic world. The anomalies in these galaxies' light, its bending, redshifting, or dispersion, could be the fingerprints of quantum gravitational effects, offering a practical testbed for theories of quantum gravity. The James Webb Space Telescope may have inadvertently become a laboratory for probing the deepest mysteries of reality, bridging the gap between the infinitely large and the infinitesimally small. The vacuum of space itself comes under scrutiny. In quantum field theory, the vacuum is not empty, but alive with virtual particles and fluctuating energy. If these galaxies reside in regions with different vacuum states, false vacuums with distinct properties, it could explain their unexpected visibility. The interfaces between these domains might manifest as gravitational anomalies or exotic particle behaviors, observable through the telescope's instruments. This opens a new frontier in studying the quantum vacuum, turning empty space into a canvas of cosmic clues. Cosmic background neutrinos, relics of the Big Bang's earliest moments, also gain new relevance. These elusive particles, nearly impossible to detect, may have different densities or flows in the regions where these galaxies reside. Their subtle effects, like gravitational lensing or fluctuations in light curves, could confirm the telescope's findings, providing a secondary line of evidence for this cosmic breakthrough. Neutrinos, once a theoretical curiosity, may become the key to unlocking the universe's deepest secrets. The James Webb Space Telescope's discovery of 750 galaxies beyond the observable universe is not just a scientific milestone, it's a pivot point in human history. It forces a recalibration of physics, astronomy, and philosophy, stretching the boundaries of what it means to exist in a cosmos without edges. These galaxies, burning their quiet fires across the void, were waiting for us. Their light, whispering tales of a universe far older, larger, and more intricate than we ever dared dream. As the telescope continues its mission, each new observation will add to this unfolding saga, a story that is as much about humanity's quest for meaning as it is about the stars themselves. The future illuminated by these distant galaxies is one of complexity, multiplicity, and unrelenting wonder. Theoretical models will evolve, observational strategies will shift, and humanity's imagination will expand to meet the challenge of a cosmos that refuses to be contained. The James Webb Space Telescope has flung open a door to the unknown, and beyond it lies a universe that is not just vast, but alive with possibility. These 750 galaxies are not the end of the story. They are the beginning, a call to explore, to question, and to marvel at the infinite tapestry of reality. The cosmos will never look the same again. What are your thoughts on this mind-bending discovery? Drop a comment below and share your awe, your questions, or your wildest theories about what lies beyond the observable universe. Hit the like button if this blew your mind, and subscribe for more updates on the cosmic frontiers being unveiled by the James Webb Space Telescope. Thank you for joining this journey into the unknown. Stay curious, and we'll see you in the next cosmic adventure.